Hello, thermal friends. I'm Armando Ursua, and I am talking about of the latent heat and specific heat. Okay, what is the latent heat? The latent heat is the thermal energy absorbed or released during phase change at constant temperature and pressure. The key characteristic is the change state, but not temperature. Now, the latent heat formula is the next, where Q is heat transferred, M is mass, and H is specific heat latent. Okay, one example of the latent heat applications is in the refrigeration, where cooling systems use evaporation to absorb heat. Other example is the power generation, where steam turbines convert phase change energy to electricity. Now, what is specific heat? The specific heat is the amount of thermal energy or heat required to raise the temperature of a unit mass of a substance by 1 grade Celsius without phase change. The key features is the applies when there is temperature change, but not phase change. Depends on substance, temperature, and process. And specific heat have two main types. The one type is specific heat at constant pressure, and the second type is specific heat at constant volume. The specific heat at constant pressure is most commonly used in open systems, allows volume to change while maintaining constant pressure, generally higher than CV for the same substance. And the specific heat at constant volume used in closed, rigid systems. Volume remains fixed while pressure may change and is important in thermodynamic cycles and gas processes. Now, the formula of specific heat is the next, where Q is heat transferred, total thermal energy added to remove, M is mass, amount of substance being heated, T is temperature change, final minus initial temperature, and C is specific heat, material property. And finally, the comparing latent versus specific heat. The latent heat is constant in the temperature, but specific heat increases the temperature. The latent heat have a phase change, but specific heat don't have a phase change. One example of the specific latent heat is ice melting, and specific heat, one example is water warming. Okay, that's all, and see you again.